Thank you so much. Okay. So today will be the last part of your atomic physics. Then from tomorrow we'll discuss about that molecular physics. So we have discussed about LS coupling for non-equivalent and equivalent electron. So today we'll first discuss that Landé interval rule to calculate the energy separation between two adjacent levels, that is basically arising due to LS coupling. Then we'll go to the JJ coupling, and for of course we'll discuss for non-equivalent electron, then for equivalent electron. Then further discussion will be on line broadening of spectroscopy. Then last topic will be hyperfine structure. So I am expecting today will be the last class of your atomic physics. Then from tomorrow we'll discuss molecular physics. So I am expecting before 10 your part will be that atomic and molecular part will be finished, and that is of course my topic. So let me see. So for today I'll first discuss about Landé interval rule. So this rule basically used to calculate the energy separation between two adjacent levels arising due to LS coupling. So what does it mean? So if you remember yesterday that we have discussed that various level due to LS coupling. If you remember, there is a PD configuration. There is a PD configuration 3P3D, and we observe many terms. So we observe many terms, right? If you remember yesterday class, we have seen that energy level like 3F2 was the ground state, or 3P3D, I guess. So for 3P3D, you have 3F2, that was the ground state. Then you have 3F3, TF4, then 3D1, 3D2.
सर वो नॉइज है
फिर से आ रहा है नॉइस?
अभी बंद हो गया,
बंद है, ओके,
फिर चालू हो गया,
फिर से आ गया।
माय गॉड, पता नहीं।
सर जैसे ही आपकी बॉडी मूव करती है तो जो वायर हिल जाता है।
अच्छा अच्छा, अभी आ रहा है?
यस सर,
अभी भी आ रहा है? अभी बताओ।
सर आ रहा है,
अभी भी आ रहा है।
हाँ
अभी ठीक है?
हाँ सर ठीक है।
Okay. So if you remember 3D3, so on. Did you remember yesterday I have discussed these things for PD configuration?
Yes sir.
So this Landé interval rule basically used to calculate that energy separation between two adjacent levels. So it can able to calculate energy separation between 3F2 and 3F3, or 3F3 to 3F4, 3D1 to 3D2, 3D2 to 3D3. That energy separation between two adjacent levels you can calculate by the use of Landé interval rule. Okay. So if you remember that spin orbit correction of energy was how much? ASO I have taken on constant, if you remember, A was something E square by 8 pi epsilon naught m square c square into 1 by r cube. So in terms of A, that energy correction is A h cross square divided by 2 into j plus 1, right? Then you have minus s into s plus 1 minus l into l plus 1. दिख रहा है आप लोगों का ये पूरा दिख
Yes,
रहा है? Okay. So that was your correction, right? Spin orbit correction. So that if you remember, I have considered this. This was the Hamiltonian. HSO, that was A L dot S. Then I have written L dot S in terms of J, L and S. And the expectation value of HSO, that was ESO. And it was giving like A H cross squared by 2, J into J plus 1 minus S into S plus 1 minus L into L plus 1. So that is your spin orbit correction. Okay. Now this is your energy correction. Now can you calculate the EJ plus 1? So what I am saying, the energy separation between two level. So this is your spin orbit energy. So energy separation delta E, that is basically EJ minus 1. So for particular L and S, I am taking L and S constant because I am calculating energy separation between 3F2, 3F3. So 3F for 3F2 and 3F3, for both L is constant, that is L equals to 3. Also S is constant, that is S equals to 1. So I am considering that L and S are constant. So then energy separation between two adjacent level will be depends upon J value because they have different J. For 3F2 J is 2. For 3F3 that J is I'm talking about these two adjacent level. So for this both L is fixed 3, also S is fixed. So 2S plus 1 is equals to 3. It means S equals to how much? 1, right? So so the energy separation between these two adjacent level will be EJ minus 1 because both have L value and S value same. So that will easily be subtracted or cancelled. That will be cancelled. So can you tell me how much it will be from this expression? So this is basically that ESO, that is basically, you can say, I'm not denoting that J. So this is basically corresponds to J. So that will be basically AH cross square by 2. Then I will not write L and S part because for both cases, for EJ and EJ minus 1, L and S part will be same. So since you are subtracting this part, two part, so automatically L and S part will be cancelled. So I'll not write that L and S part, only I'll write J part. So it will be J into J plus 1 minus J into J minus 1. So how much it will be now? H cat square by 2, J square plus J minus J square plus J. So J square will be cancelled. So simply you will get
H cross J.
good. Now can you calculate energy separation delta E equals to EJ plus 1 minus EJ? How much it will be?
सर किसके लिए?
Energy separation between J plus 1 level and J level. So this was EJ minus 1. Now I am calculating
J plus 1 AH cross.
exactly. So you can calculate also A H cross square by 2. Then for J plus 1, it will be how much? J plus 1 into J plus 2, right? Minus J into J plus 1. Okay. Which means delta E will be H cross square by 2 J square plus 3J plus 2, right? And it will be J square minus J. J square will be cancelled, right? And this will give you H cross square by 2 into 2J plus 1. Because 3J minus 2J will be 3J minus J will be 2J, and you have 2. So 2J plus 2, from both term you will get 2 common. So if you take 2 common, you will get J plus 1. And these 2 will be cancelled. So it will be H cross square into J plus 1. Okay. Similarly, you can calculate that energy separation E equals to EJ plus 2 minus EJ, EJ plus 1. How much it will be? It will be simply H cross square by into J plus 2, right? So nothing. That separation, it depends upon this J, upper J, right? For this case, H cat square into J. For this case, upper level is J plus 1. So it will be H cat square into J plus 1. For this case, upper level is J plus 2. So it will be H cross square J plus 2. So now I am talking about, have you written this part? Have you written this part?
Yes, sir.
Okay. Now can you tell me what will be the energy separation between 3F2 and 3F3 in terms of A? Can you tell me? What will be the energy?
3H cross square.
So yes, good, very good. So if you see what I have derived this part, the conclusion was that, so energy separation, that total angular momentum will be in energy separation, total angular momentum will be corresponds to upper level. Is this part clear?
सर ये और एक बार बात
हाँ, देखो यहाँ पे कौन सा आपका J है? जैसे आपका सपोज मान लो जब मैंने EJ माइनस ऑन किया था, ठीक है, या EJ प्लस ऑन माइनस CJ, या EJ प्लस 2 minus CJ. So that separation was proportional to J, right? That proportional to J plus 1. That
Yes.
proportional to J plus 2. तो इसमें देखो कोई सा एक इक्वेशन ले लो, आप ये वाला इक्वेशन ले लो, तो कौन सा J होना चाहिए आपके हिसाब से? कोई सा भी एक इक्वेशन ले लो और कोई आप बोलो कौन सा, ये इक्वेशन अज्यूम करो आप, इसमें बताओ ये इक्वेशन अगर लोगे तो इनमें से J कौन सा होगा?
corresponds to upper state.
एग्जैक्टली तो आप J मतलब J obviously J minus 1 से बड़ा है, so obviously this will be your J. No.
Yes, sir.
So here what will write? The separation will be H cross square into 3. You can take other equation also, same. So here I will consider J plus 1 equals to how much? J plus 1 corresponds to this. I will consider J plus 1 corresponds to this and J corresponds to this. So separation was depends upon J plus 1 and J plus 1 is this. So any equation you can use. The main thing is that that higher J that will be corresponds to what? Higher J corresponds to your J plus 1 upper state, right? Is this part clear what I am saying?
Yes, sir.
Yes, sir.
Okay. So this is the Landé interval rule. So by using this rule, you can calculate the energy separation between two adjacent level. Of course, here I have considered like 3F2 and 3F3 for both case. You can clearly see for both cases, L value and S value are same. So that's why I have neglected, or it will be cancelled that I have neglected that L and S term. So only I have taken J term for that calculation in that energy separation. Okay. So it can calculate to energy separation between two adjacent level, and that level basically arising from LS coupling. Okay.
सर
Yes.
अगर एस के और एल की वैल्यू डिफरेंट होगा तो ये फॉर्मूला एप्लीकेबल नहीं है ना
नहीं,
अपर
फिर
लेवल
आपको
का
लेना पड़ेगा पूरा
जनरलाइज वाला
हाँ, that factor आपको लेना पड़ेगा, but that will not ask. Okay, yeah, you can, if they ask, you can take, because you know for both the level you know L, S and J, right? So if you know, then you can easily calculate. Just you have to do some extra calculation for L and
Okay,
S also. Okay. Okay. Shall I erase?
yes
Shall I
sir.
erase? Okay. Now we'll go to JJ coupling. कैसे फीलिंग आ रहा है आप लोगों का एग्जाम के पहले? कैसे फीलिंग आ रहा है?
सर मैं तो पहले से नेट निकाल रखा है, तो लेकिन थोड़ा सा ये है कि
नेट पहले से हो गया आपका ना?
हाँ सर, मेरा तो हो रखा है।
वेरी गुड।
बट ये है कि हाँ, पहले जैसी एंजाइटी नहीं है, पहले बहुत ज्यादा एंजाइटी होती थी।
अच्छा अच्छा, चलो
हाँ सर।
पर अच्छा होगा ना?
हाँ
JRF
सर,
तो
मतलब कि टेस्ट तो अच्छे जा रहे हैं। JRF के लिए पूरी तैयारी में बैठा हूँ सर।
अच्छा, बाकी लोगों का?
सर टेंशन होता है।
अच्छा, नहीं, टेंशन होना अच्छी बात है, टेंशन होना बहुत अच्छी बात है
सर
ना?
एक्चुअली सर बहुत ही रिवीजन करना बाकी है सर। तो
देखो, पढ़ाई में कभी ऐसा नहीं लगेगा, एग्जाम के पहले तो ऐसा लगेगा कि सारी चीज़ बाकी है, बट अगर ऑनेस्टली मेहनत की हो अपने तो आराम से हो जाएगा। मैं अपना पर्सनल एक्सपीरियंस बता रहा हूँ, ऐसा नहीं कि मैंने कंटिन्यू जितने बार दिया हुआ है, पहली बार मेरा सबसे अच्छा रैंक था। उस टाइम भी मैं सोच रहा था कि मेरा इस बार प्रिपरेशन सही नहीं है, पर बिलीव नहीं करोगे 20 में से 19 उस बार ठीक हुआ था। वैसा नहीं होता है, अगर आपने मेहनत की हो ना, ऑब्वियसली
सर
होगा।
2 बार देने के बाद निकाला, तीसरी बार में।
कौन? आपने? अरे वो कोई नहीं, वो होता है, कोई प्रॉब्लम नहीं, बट अच्छे से जो मेहनत किए हो ना, आप लोगों ने बहुत मेहनत की हो
सर
जाएगा। बस पॉजिटिव ये रखना पड़ेगा आपको, है ना, कि हाँ आपने मेहनत की हो तो ऑब्वियसली होगा। ठीक है, ये भी आपका मल्टी इलेक्ट्रॉन के लिए है। ठीक है, तो again I will draw atomic level. Suppose this is your nucleus and this is your electronic orbit. And this is your electron number 1. It has orbital angular momentum L1, spin angular momentum S1. This is your electron number 2, is orbital angular momentum L2, spin S2. And this is your electron number 3, is orbital angular momentum L3 and spin is S3. Okay, so you have many electron and each electron has orbital and spin angular momentum. Okay, so of course they will have magnetic moment also, like mu L, spin part and orbital part. But if for heavier element, Z greater than 30, for heavier element Z greater than 30, there is no boundary, but yes, Z should be greater than 30. So for this case, the spin orbit interaction is dominant. Okay, spin orbit interaction is dominant. What does it mean? That each electron will have L and S, so they will interact each other. So let us assume electron number 1 has orbital part L on, S spin part S on. They will interact each other. Similarly, L2, S2 they will interact each other, and L3, S3 they will interact each other, and that interaction actually dominant. Okay, so earlier when that lighter element, there is that part was dominant, like L interaction, S interaction was dominant. But for this case, LS interaction is dominant. L and S interaction, that is dominant. And reason is simple, because ESO that was proportional to Z to the power 4. So ESO itself representing that spin orbit interaction, LS interaction. So since Z you are taking heavy, so of course that part will be dominant. So in that case, what will happen? Suppose you have electron number 1, its orbital angular momentum L on and spin is S on. Second electron is orbital part L2, spin part S2. So L on S on will interact first. So that will provide you J1. So J1 can be L on plus S on to L on minus S on. And this J2 corresponds to electron number 2, that will be mod L2 plus S2 to mod L2 minus S2. So there is a spin orbit interaction first, and that will give you total angular momentum J1 and J2. Then finally there is an interaction between J1 and J2, and that will provide you resultant J. So it may be J1 plus J2 to J1 minus J2. Okay, is this part clear?
Yes.
Okay. So there are two cases. So there electron can be non-equivalent. And electron can be equivalent. Okay, so I'll discuss one by one. So let me take first a non-equivalent electron. Okay, so I'll discuss this part first. So let us take electron 2p on 3p on. Okay. So for 2p on, let us take orbital part. Obviously for p it will be on, and corresponding spin is S on, that will be half. And for 3p on, L2, that is its orbital part, that will be again on, and its spin, since this is the electron, obviously that for single electron spin will be half. So there will be interaction between these two. So let us denote that J will be mod L on plus S on to mod L on minus S on. So how much value will get?
3/2 and half.
2/2 to half.
Good, 3/2 to half. There are two values, and similarly same thing will be repeated for electron number 2, because they have identical L and S, right? L2 is same as L on, S2 is same as S on. So again J2 will be 3/2 and half. So how you used to write that spectroscopic term for JJ coupling? So term used to write J1, J2, J. J1, J2, J. Now we'll take different combination. So first combination I'll take 3/2 3 by 2. I mean, J1 equals to 3 by 2 and J2 equals to 3 by 2. Okay. So how much J will get? How much J will get? J will be how much? Mod J1
320.
to J1 plus J2 to mod J1 minus J2, right? So J1 plus J2 will provide you 3 and J1 minus J2 will provide you 0. So 3, 2 on 0, right?
Yes.
So corresponding term will be, how will write? 3 by 2, 3 by 2 and 0 on 2, 3. So this is your first combination. Similarly, second combination B, I'll take J1 equals to 3 by 2, J2 equals to half. Okay. So if you do J, what will be the J now? 2 and on, right? Right?
Yes.
2 and on, because J1 plus J2, 3 plus 1 by 2, 4 by 2, that will provide you 2. And J1 minus J2, 3 minus 1 by 2, 2 by 2, that will be 1. So there are 2 J allowed here, and corresponding term will be what? 3 by 2, 1 by 2, and on 2. Is this part clear?
Yes.
Okay. Now there are 2 more possibilities. Third, it can be J1 can be half and J2 can be 3 by 2, right? Because you have J1 3 by 2 half, J2 3 by 2 half. So I have taken 3 by 2, 3 by 2 combination, 3 by 2 half combination. Now J1 can be half, J2 can be 3 by 2. Again, you will get same J value like 3 by 2 and half combination. So J will be same. What it will be? 2 and on, right? 2 and on, right? Is this part
Yes,
clear
sir.
to all? Is this part clear to all?
Yes, sir.
Yes, sir.
Okay. So its term will be it will be half 3 by 2
1, 2.
on 2, right? And this part and this are degenerate level, because 3 by 2 half you can interchange. So here it is 3 by 2 half, na? Here half and 3 by 2, they have same value. This thing you can interchange. So they have same energy. Okay. So they are basically degenerate level. Is this part clear?
Yes, sir.
Okay. Now last combination is this concept clear what I am saying? You
Yes,
can
sir.
interchange J1 and J2. Here 3 by 2 and half 3 by 2. So you can write it like 3 by 2 half. You can interchange and they have same J. That's how you can interchange. Okay. Last combination is J1 equals to half, J2 equals to half. So what about J now?
1, 0.
Good, 1, 0. So term will be half,
1 by
half,
0, 1.
good, 0, 1. So these are the thing you got. Now you have to arrange this term. Okay. So how will arrange? So you have to arrange this term. So you have to keep in mind
सर यहाँ तो लोअर एनर्जी पे लोअर जे होगा ना सर?
exactly. So for
half
higher
of
J,
half of 0.
good.
No,
Higher J,
higher energy.
higher will be the energy. Okay. So first you have level. You have 2p on 3p on level. Okay. This is before interaction. So after interaction it will break. Okay. So it will be break.
Hello, sir.
Yes.
You're not audible in between, I think.
Yes. Yes. Can you
You
hear
are
me?
not, I think, now I can hear.
Yes.
Between, I don't hear what you said. The question means.
Sorry, I'm not getting what are you saying. Your voice is. I didn't get complete voice. Can you please repeat?
Hello, sir. In between, you have said something, na, that while drawing that diagram. Am I audible?
Yeah. Okay. Okay. Yes. What I'm saying, how will arrange this term? You got many term, right? So how will arrange? There will be. I mean, for every term, there will be different energy, right? So higher the J value, higher will be the energy. Higher the J value, suppose you got this combination, if you remember, 3 by 2, 3 by 2. This combination you got, right? And it has many values, 0, 1, 2, 3. So among these, which one will have higher energy?
3.
First 3. Okay. So this is
Okay,
your
sir.
this is your first unperturbed term. So after LS coupling, it will be break. So this will be 3 by 2, 3 by 2. So higher J1, J2 combination, higher J1, J2 combination that will be upper level. So 3 by 2, 3 by 2, that is higher J1, J2, that will be upper level. Then you have 3 by 2, 1 by 2. You have 2, 3 by 2, 1 by 2, but they are degenerate. And last is half. After that, they break further, right? 0, 1 to 3. Right. So I have to draw like this 0, 3, 2. So this will be J equals to 0, 1, 2, 3. So this is J value. Okay. Can you hear me?
Yes, sir.
Yes, sir.
Okay. Then you have this part, it will again be break. So it will be what? J equals to, what was that value? 1 and 2, right?
Yes, sir. Okay.
And last part was 0 and 1, right? So this is J value. I have already mentioned J here. So this is J value. Okay. Is this part clear?
Yes, sir.
Is this part clear to all?
Sir,
Yes.
एक मेरा बेसिक डाउट है, कैन आई आस्क?
Yes.
सर, इसके पहले हमने जो भी ट्रांजिशन दिखाए थे ना, उसमें हम जब अनपर्टर्ब्ड लिख रहे थे तो हम ट्रांजिशन दिखा रहे थे ना, 2p1 to 3p1. सो यहाँ आपने जो लिखा है एक ही स्टेट जो दिखा है, इसका मतलब क्या है? वो कंबाइंड स्टेट है, ये है, और
कौन सा?
अनपर्टर्ब्ड टर्म में
हाँ,
पहला 2p1.
हाँ, ये आपका अनपर्टर्ब्ड है, मतलब ये आपका अनपर्टर्ब्ड है। यहाँ पे इधर एलएस कपलिंग और जेजे कपलिंग हो सकता है, बट ये आपका मेंशन कर देगा वो लोग। मैंने 2p 3p ले लिया, आपको बोल देगा कि जेजे कपलिंग के थ्रू क्या क्या टर्म मिल सकता है, किसका हायर एनर्जी होगा, किस कॉम्बिनेशन का लोअर एनर्जी होगा। तो ये बेसिकली मैं ट्रांजिशन में नहीं दिखा रहा हूँ, यहाँ पर ट्रांजिशन का कोई जरूरत नहीं, जस्ट स्प्लिटिंग में क्या क्या एनर्जी लेवल मिलेगा वो आपको देखना पड़ेगा। एलएस एंड जेजे कपलिंग में तो कोई ट्रांजिशन नहीं है, जस्ट आपको देखना पड़ेगा कि इस एलएस कपलिंग में क्या क्या आपको एनर्जी लेवल मिलेगा, जेजे कपलिंग में क्या क्या एनर्जी मिलेगा, इसका ग्राउंड स्टेट क्या होगा, ये सारी चीजें। जीमान इफेक्ट, ठीक है, फिर आपका पासन बैक इफेक्ट, इसमें आपका ट्रांजिशन देखना चाहिए। इवन पासन बैक इफेक्ट में भी जरूरत नहीं, मेनली आपको जीमान इफेक्ट में ट्रांजिशन देखना पड़ता है। बाकी जो पार्ट है मैं बता दूंगा आपको, ठीक है। यहाँ पे जरूरत नहीं, यहाँ पे जस्ट आपका योर मोटिवेशन इज टू कैलकुलेट द टर्म ड्यू टू जेजे कपलिंग। So since you can clearly see there was only one energy level, and due to JJ coupling you can see how many energy level you are getting. Okay. This
Okay,
part.
sir.
Now I'll calculate for equivalent electron. मैं आपको क्वेश्चन का ट्रेंड बता रहा हूँ। जैसे आपका पहले तो पहले चैप्टर में आपका रिड्यूस मास का जो कॉन्सेप्ट है ना, उसके बेस में क्वेश्चन दे सकता है, और इधर जो डिस्कस किया था आयनाइजेशन पोटेंशियल या बाइंडिंग एनर्जी के फॉर्म में, उस फॉर्म में क्वेश्चन दे सकता है। दूसरे में आपका क्या है, जो आपका स्पिन ऑर्बिट करेक्शन के कॉरस्पॉन्डिंग हैमिल्टनियन दिया जाएगा, और आपको बोलेगा कि दो एनर्जी लेवल के बीच में कितना गैप है, या फिर स्पिन ऑर्बिट कपलिंग जेड के ऊपर डिपेंडेंट है। तो सपोज मान लो आपको हाइड्रोजन के लिए गिवन है कि हाँ स्पिन ऑर्बिट कपलिंग फॉर 2p लेवल इज दिस, सो लिथियम के लिए कितना होगा और फॉर अदर एलिमेंट के लिए कितना होगा, ये इंपॉर्टेंट है। और जीमान इफेक्ट में आपका जो मैंने आपको सिखाया है एज इट इज वैसे ही करना पड़ेगा आपको। नंबर ऑफ ट्रांजिशन, फिर आपका सेपरेशन बिटवीन टू कंपोनेंट इन टर्म्स ऑफ लैम्डा, इन टर्म्स ऑफ एनर्जी, इन टर्म्स ऑफ फ्रीक्वेंसी, ठीक है, कितना कंपोनेंट मिलेगा जैसे करवाया। क्वेश्चन बैक इफेक्ट में भी कितना एक लेवल कितना लेवल में सब लेवल में आपका ब्रेक हो सकता है ना, सर जैसे सिखाया वैसे। और इसमें आपका एलएस जेजे कपलिंग में बेसिकली ग्राउंड स्टेट ही पूछा जाता है कि हाँ नाइट्रोजन का ग्राउंड स्टेट क्या हो सकता है, या D5 का ग्राउंड स्टेट क्या है, PQ का ग्राउंड स्टेट क्या है, ठीक है। जेजे कपलिंग में आपको पूछा जा सकता है कि इनमें से कौन सा ग्राउंड स्टेट हो सकता है ना, या कौन सा कॉम्बिनेशन नहीं हो सकता है। J1 J2 गिवन होगा, आपको बोलेगा कौन सा कॉम्बिनेशन नहीं हो सकता है इनमें से, ठीक है। तो जैसे आपको पढ़ाया गया है एज इट इज ऐसे पढ़ के जाओ, एंड यू विल रियली एंजॉय बिकॉज द वे आई एम टीचिंग, मतलब जिस वे में हो रहा है ना ये, मतलब फेनोमेना हो रहा है उस वे में मैं आपको बता रहा हूँ। इवन जहाँ पे जो ट्रांजिशन का जरूरत है मैं दिखा रहा हूँ, फिर आपको शॉर्टकट बताया हूँ, ठीक है। चलो इसका इक्विवेलेंट का क्या है, सपोज मान लो आपका p² इलेक्ट्रॉनिक कॉन्फ़िगरेशन। तो इसमें दो केसेस हो सकते हैं। सपोज मान लो आपके पास एक पॉसिबिलिटी तो ये है J1 नॉट इक्वल टू J0, सॉरी नॉट इक्वल टू J2। तो उसमें क्या करोगे, आपका जो रिजल्टेंट J होगा वो क्या होगा, J1 प्लस J2, J1 माइनस J2। दूसरा पॉसिबिलिटी क्या हो सकता है, आपका रूल है कि J फाइंड आउट करने के लिए, ठीक है। दूसरा है J1 एंड J2 बराबर है, J1 एंड J2 बराबर है, तो उसके लिए जो आपका रिजल्टेंट J होगा मॉड 2J माइनस 1, या J मीन्स आइदर J1 और J2, ओके, इज नॉट लाइक से लेफ्ट हैंड साइड J, मॉड 2J माइनस 1, मॉड 2J माइनस 3, मॉड 2J माइनस 5 एंड सो ऑन। आपका रूल है अरेंजमेंट करने के लिए। तो जैसे आपको देखो p² है, तो p² में 2 इलेक्ट्रॉन है, तो इसका J1 एंड J2 मिल जाएगा आपको। तो p² में आपका एक इलेक्ट्रॉन का एलॉन कितना हो जाएगा, ऑन हो जाएगा, उसका कोरस्पॉन्डिंग एस ऑन कितना हो जाएगा, हाफ हो जाएगा। सेकेंड इलेक्ट्रॉन का एलॉन कितना है, ऑन एस ऑन हाफ, सेम होगा। तो इसमें J1 का कॉम्बिनेशन क्या होगा, 3/2 हाफ। So what I am calculating that spectroscopic term due to equivalent electron, and that equivalent electron is p². So for p² for one electron, since they are in L orbit, L1 will be on, and obviously for a single electron S1 will be half, and both are identical, so we can write like this. And please let me write this in L2 and S2. So J1 will be 3/2 half, J2 will be again 3/2 and half. Okay, now we can clearly see when you will take 3/2 3/2, when you will take 3/2 3/2, your J will be different. J will be how much? So J1 and J2 are same, so what will be J now? So I told you,
J 20 sir, 20.
so you see 3 by 2, 3, both are 3 by 2, 3 by 2, and j, how to find out j, that I told you 2j minus 1, 2j minus 3, and so on, and up to what limit you have to go? Up to 0. So negative j will not be allowed, so up to 0 you have to go. So 2j minus 1, how much it will give? So j means either j1 or j2. So let me take j1 because both are same. So 2 into 3 by 2 minus 1, it will give you 2. Next is 2j minus 3. How much it will give? So 2 into 3 by 2 minus 3, that will give you 0. So I have to go up to 0 because negative j is not allowed. Okay, so I will not extend further. So j will be 0 and 2. Is this part clear?
Yes.
Is this part clear to all? Is this part clear?
Yes sir.
सर बीच में 1 नहीं आएगा, 210 हम बीच में से वैल्यू ले
नहीं
रहे थे वैसे.
नहीं आएगा. आपका रूल क्या था? j इक्वल्स टू मॉड 2j minus 1 mod 2j minus 3 mod 2j minus 5. ये वैल्यू अलाउड है. मतलब you can clearly see separation between two level, their separation will be delta j equals to 2. Earlier what you used to write mod j1 plus j2 to mod j1 minus j2. जितना सारे इंटरवल में वैल्यू है सारे अलाउड है, बट यहाँ पे ऐसा नहीं. 2j minus 1, 2j minus 3, 2j minus 5 like that. Okay. Okay, so this is the one part. Second part, so here j will be what? 0 and 2. Second half. What will be j now? What will be j? So 2j minus 1.
Sir,
First,
0 sir, 0 sir.
only 0 will be there. Next, 1 by 2 and 3 by 2. So how much you
3
will
by
get?
2, 1 by 2, 2, 1.
So j will be how much? 2,
2 1
2 on, right?
2 1 2 1, sorry.
So it will be 2 on and 2. And you will take another combination that will be 3 by 2 half. Again, it will give you same. Right? So you can take this combination also. But they are degenerate. 1 by 2, 3 by 2. Again, you will get j equals to 1, 2. Is this part clear? Is this part
Yes.
clear to all?
Yes, sir.
Time कितना हुआ?
7:30 sir.
7:30. So you have to take 5 minute break, right?
Okay sir.
Okay, sir.
Okay. Now we'll discuss hyperfine structure. So you know there is a spin orbit coupling, right? So there is a spin angular momentum and orbital angular momentum. So they interact with each other, and that provide you total angular momentum J, right? So now since you know that nucleus has spin, right, and its magnetic moment. So that nuclear spin will interact with total angular momentum, and that's why there is a further splitting of energy level. So initially you have spin orbital angular spin orbit coupling that provided you total angular momentum J. Now, yes, are you asking something?
मैं आपने जो भी डिफाइन किया वो चीज नहीं कर
Sorry.
सर जस्ट आया मैं क्लास में
Okay, yeah, just start over. So what I'm saying that you have J, right, total angular momentum that was resulted from spin orbit interaction, L and S interaction. Now you have nuclear spin, sorry, yes, nucleus, and nucleus has spin and its associated magnetic moment. So this magnetic moment or nucleus spin angular momentum will interact with total angular momentum J, and that will split your energy level further. So let us define, or let us write first hyperfine structure.
सर ये
Yes,
जो हम बोल रहे हैं ये सब सभी लास्ट ऑर्बिटल का बोल रहे हैं या
exactly. The question is good, but yesterday you remember I told you जितना सारे आपका fully filled है. Let us take example. You have sodium. Okay, you have sodium. Then its configuration was 1s2, 2s2, 2p6, right, and 3s1. So that will basically provide you 0L and 0S. So whatever you are getting contribution, that will be from what? 3s, right? But
yes,
let us assume in some other case that last electron configuration is P2 or something like that. So it will have, there will be LS or JJ coupling depending upon that how much heavy this element is. So that will provide you J, right? So after LS coupling, you will get many energy level, right? After spin orbit coupling, you will get many energy level, and that J for ground state you will have J value, right? That J will interact with that nuclear spin angular momentum. Okay.
सर अगर P3 सॉरी D5 होगा
हाँ.
तो लाइक हाफ फील्ड कोई लास्ट ऑर्बिटल हो तो उसके केस में क्या हो?
उसके लिए तो आपका ये J नहीं होगा ना, वो तो फिर आपका सिर्फ सिंपल केस आ जाएगा, है ना, जहाँ पे वहाँ पे स्पिन ऑर्बिट का कपलिंग ही नहीं है.
हाँ, तो मैग्नेटिक मोमेंट न्यूक्लियर मैग्नेटिक मोमेंट किसके साथ इंटरेक्ट करेगा?
न्यूक्लियर मैग्नेटिक मोमेंट फिर आपका स्पिन के साथ इंटरेक्ट करेगा.
ओके,
बिकॉज यू सी nucleus has magnetic moment and spin has magnetic moment, so they can interact, right? They may interact, no?
yes.
So that is one possibility. So let us assume J is your total angular momentum. Okay, and I is nuclear spin angular momentum. Okay, so what is hyperfine structure? The splitting of energy level, splitting of energy level due to total angular momentum J and nuclear spin angular momentum I interaction. Okay. So if I is the nuclear spin angular momentum, so what will be the its value? It will be root over I plus 1 H cross, right? This is the
Yes.
spin angular momentum. And its Z component will be Iz will be Mi H cross, where Mi can be -1 to minus I to plus I. And what will be the nuclear magnetic moment? Mu I. Mu I is here nuclear magnetic moment, and that will be how much? Landé Z factor Zi, then E by twice mass of proton root over I into I plus 1 H cross. Okay. Now, if you consider I H cross, or if you combine H cross with E and E H cross by twice MP, that is nothing but nuclear magnetron. So Gi mu n, that is nuclear magnetron, that is
भी होगा,
sorry.
एक B external भी होगा.
No, that I'm only calculating the magnetic moment associated with nuclear spin. Only magnetic moment I'm calculating. I'm not considering here that Hamiltonian. So when you'll take Hamiltonian, that will be mu dot B, right? But
Yes, sir.
I'm only calculating that magnetic moment associated with nuclear spin. So that will be G factor E by 2 MP. Then I is value is root over I into I plus 1 H cross. Now if you bring H cross here, so E H cross by 2 MP, that is nothing but nuclear
Yes, sir.
magnetron mu n, and you have root over I into I plus 1. Okay. So here mu n is EH cross by twice MP. Okay. So MP is nothing but 1836 times mass of electron. So if you substitute M in place of MP, if you substitute this value, then EH cross by twice ME will provide you Bohr magnetron. So basically mu n will be nothing but Bohr magnetron divided by 1836. Okay. So this is the relation between mu n and mu b. So now, so there is an interaction between J and I. So for that, let me define F. F is your hyperfine quantum number. Then F can be what? Mod I plus J to mod I minus J. Okay. So in vector form, it will be F equals to I vector plus J vector. Okay. And its magnitude will be like this. So there is a further splitting of energy level due to I and J interaction. I is nuclear spin and J is electronic total angular momentum. Now let me take one example. Suppose sodium D online. Sodium D online. So if you remember, D online was corresponds to 2p 3 by 2
Yes, sir.
2s half, right? That was it given by. Now if I for sodium is half, then there will be splitting of 2p3 by 2, right? Splitting of 2p3 by 2 as well as splitting of this. Now so then you may get answer of your question. If it is s orbital, then what will be the interaction? So there will be interaction with I with only that spin magnetic moment, because it has for the ground state, obviously L is 0. So
Yes.
sorry, here for D1, let me that notation is 2p half. For D2, I have taken 2p3 by 2 according to book. Okay, that's nothing
सर
but nothing.
सोडियम के लिए तो सर D5/2 होता है ना सर?
Let me take. This is your example. Yes.
ओके 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 मतलब कि
I have
आपने माना
taken-
है ना सर बस.
I have considered. So you are correct. If you calculate, you will get 5 by 2. But
Yes, sir.
if they provide you I, okay, they will provide you. No need to be worried. In exam, they will provide you I. I have given to make your life simple. I have considered I equals to half. If I take I equals to 5 by 2, then it will be complicated, because it will get many number of lines and it will be complicated. Okay. And in exam, I think they will not ask like that. So it will be very simple. If they are not providing you that value, definitely you can calculate that, right? But I have given that example. Let me take I equals to half here. So what will be that splitting here? You will get 2 line, right?
Yes, sir.
If
2
you
and
got-
1.
that will be what?
2 and 1, sir.
2 and 1 or 1 and 0, because I have considered here half,
Half, sir. तो 1 and 0, sir.
1 and 0, right? And for this, again you will get 1 and 0. Is this part clear to all?
Yes,
Yes.
sir.
In exam, they will provide you I. If they not provide, then you can calculate according to cell model, by using cell model. So now you got this line. So 2p half further splitted. So this is your spin orbit splitting, and spin orbit splitting further splitted into 2 component because of nuclear spin, and 2s half also splitted into 2 parts. Now you see there is a on line here, right? From 2p half to 2s half transition, you got only one line. You can see here how many line you will get. The selection rule for this hyperfine is delta F 0 plus minus 1, but 0 to 0 is not allowed. Not allowed. Abhishek, good, very good question. I appreciate you, because it should be 5 by 2. You have certainly you have calculated, but I have taken, in fact, in exam they will provide you. Okay, now can you tell me how many transition line will be observed here? Anyone?
3. Sir, 3.
So there will be 1 to 1 transition, right? There may be
Yes.
1 to 0 transition, because here also delta F how much 1. Is there possibility 0 to 0 is not allowed, right?
No, sir, not allowed.
Then
0 to 1 allowed.
good.
0 to 1, sir.
Now you can see you got 3 lines here. So before interaction you have only 1 line. Due to fine structure you got 3 lines. Okay. So this is the part of hyperfine. So very simple physics is there. Just I and J interaction. That's it. Okay. Is this part clear to all? Is this part clear to all?
Yes, sir.
Now I'll discuss a little bit about line broadening. So what is basically line broadening? Shall I erase this part?
Yes, sir.
तो कल से शुरू करते हैं मॉलिक्यूलर फिजिक्स.
Yes, sir.
In line broadening, I'll discuss only about your natural broadening and Doppler broadening. The second is Doppler broadening. Okay. Okay. So first I'll discuss natural broadening. Okay. So you see, suppose this is your two energy level, E2 and E1. Okay. Let us assume their separation is some 2 electron volt. Okay. When atom will make transition from here higher state to lower state, there will be emission of photon. So you are expecting that energy of photon will be how much? 2 electron volt, right? That is your expectation. So if you see that intensity versus wavelength line, so you may expect there will be sharp one peak. Along this axis you have intensity, and along y-axis let us assume energy. So if you see, if you are observing this outcoming photon, so what you will notice? You will notice there is a outcoming, or this photon will have only one energy. At this energy, at energy 2 electron volt, you will get sharp peak. This is your expectation, right? Is this graph clear to all?
Yes.
So you are looking this, observing this photon, you are measuring this intensity versus energy, energy of outcoming photon. So you are expecting that intensity should be high at energy 2 electron volt, and beyond or below this there will be no intensity. But in reality, if you see that spectrum is not like such, there is some broadening. So around 2 electron volt you will have peak, but below also some intensity you will notice. This side you have intensity. So this is your expectation and this is reality. Now why it is happening? The answer is simple. So if you remember, I told you that when electron or atom staying here, it has some lifetime. But we never know at what time. This is the lifetime of this level. And within this time, this atom will come to here. But we never know up to at what time this will come. So there is an uncertainty in transition, and maximum uncertainty in time will be how much? Did you get what I'm saying? So we never know when this electron or atom will come from E2 to E1. Okay. Within this time it will come back, but we never know. Okay. So there is a uncertainty in time for this atomic transition. So maximum uncertainty in time will be how much? Delta T. That will be lifetime of level. Suppose lifetime is 80 seconds. 80 nano, let us take in nanosecond, 50 nanosecond. So it may come 0 in 0 nanosecond, it may come 1 nanosecond, within 1 nanosecond, it may come within 15 nanosecond, but we never know. So there is an uncertainty in time. And we know from Heisenberg uncertainty principle, delta E into delta T, that will be h cross by 2. So if there is an uncertainty in time, of course there is an uncertainty in energy. So if there is uncertainty in energy, obviously you will not get a sharp peak. You will get delta amount of shift above, beyond the peak, also below the peak. So due to uncertainty in atomic transition, there is a broadening of spectral line or spectrum, you can say. Okay. Is this part clear? Now,
Yes, sir.
now in terms of frequency, what you can write? So in place of delta T, I'll use tau, and that should be equal to how much? H cross by 2. So delta E will be simply H cross by 2. So now what we can write? Uncertainty in frequency, let us denote this notation delta omega n. Omega n means natural frequency, and its uncertainty, it will be how much? So of course there will be tau here, right? So it will be how much simply? So it will be 1 by 2 tau, right? Because E equals to H cross omega, and that H cross will be cancelled with this. Is this part clear to all?
Yes, sir.
Okay. Now can I write in terms of nu? Uncertainty nu, it will be how much? So nu omega is how much? Omega n 2 pi nu n, right? So this will be how much? 1 by 4 pi into tau. Right? So this is uncertainty in frequency, and also you can calculate in terms of lambda also, because you know nu equals to nu n equals to c by lambda n, right? What we can write? C by lambda n square delta lambda n, that should be equals to how much? Delta nu n. And I have taken only modulus because I have to check only how much spread in that lambda. So delta lambda n will be how much now? Lambda n square by c into delta nu n. And you know delta nu n from here. You can substitute. So we can calculate delta lambda n also. Is this part clear to all? Is this part clear to all?
Yes, sir.
Shall I erase?
Yes, sir.
Now, second is Doppler broadening. Okay. So this Doppler effect, you know, right? Suppose you have source. This is your source, and it's moving with some speed v, and the frequency of the source is Suppose this is your electromagnetic source. So frequency of this source is nu naught, and there is an observer here. Okay. So let us assume that observer observe the frequency, that is omega. So omega minus omega naught will be how much? So this is a, suppose this is your source. It is producing electromagnetic wave, that is omega naught. And if it is moving with speed v, observer will observe the different frequency as compared to its original frequency. Of course, it will observe same frequency when it will move perpendicular to observer. But if it is approaching or moving away or moving at some angle, of course it will observe some different frequency, and that frequency I have assumed omega. So that frequency omega, that will be how much? Omega minus omega, it will be plus minus omega by c into v. So plus, when it will be plus, when that that source will approach, right? And that time observed frequency by observer will be high as compared to its original frequency. So this is known as blue shift. And negative corresponds to when the observer moving away from, sorry, source is moving away from observer, then there will be minus sign. When source is moving towards the observer, there will be a plus sign. At the time that observed frequency by observer will be high as compared to its original frequency. But if it is moving away, the observed frequency will be less as compared to original frequency, and that's why you have to take minus sign. So this is when the observer is, when the source is moving away. And that corresponds to, this is known as a red shift. Red shift means, so blue shift means there is a increase in frequency. So there is an increase in, or the observed frequency is high. So it means observed frequency is high, it means observed wavelength is low. So that's why blue shift, because wavelength is getting less, that's why it is blue shift. But when that energy is it is moving away, observed frequency will be less, wavelength will be large, that's why it is known as red shift. Okay, now you know V. V is how much? For atomic case, I'll take, of course. So let us take our example. Suppose you have container. So same formula I'll use for same concept I'll use for spectroscopic term also. So suppose this is your chamber. This is your chamber. It contains many number of atoms. And they are not actually they are not at rest. They are moving randomly, right? Suppose this is the observer. Okay. So some atoms, let us assume, moving this side. Some atom moving this side. Some moving this side. And of course some moving at some angle. Okay. So when the atoms inside chamber or inside your experimental setup, you have that hot atoms. Hot atoms, they are not at rest, they are actually moving at very high speed. And since they are hot, so their electronic transition actually producing that that light or that frequency. Did you get what I'm saying? That atom inside the sample, they are hot and they are randomly moving, and whatever light or frequency is producing because of their electronic transition. But since they are not at rest, So let us assume they are producing some frequency omega naught. But since this atom, they are not at rest, they are moving randomly. Some of them are moving towards the observer. Some of them are moving perpendicular to this. Some of them are moving at some angle. Some of them are moving away from that observer. So whatever frequency or energy is emitting due to electronic transition, the observer will observe not only a single frequency, but it will observe many frequencies. So if the emission frequency is omega naught, so in the spectrum you will get this kind of plot. So this side you have again intensity, and this side omega, and peak corresponds to omega naught. But of course you will get this intensity also, and this is originating due to the motion of electron. Okay, if it is this part omega, if some frequency you see it is higher than the omega naught, that corresponds to when the observer when the atoms are moving towards observer. Some of them you see less than omega naught. So why this component is coming? Because some of them are moving away from that observer. Okay, so that's why you will get this kind of spectrum. And same thing, the Doppler effect, due to motion these things are happening, or this shift is happening. So this will be how much? Let us assume delta omega d, and that will be again plus minus omega c. And v, what will be the v now?
So 2.2 into 10 to the plus 6 by n.
V is the most probable distance, because we are talking about that atom here, right? So that will be how much? 2 kVt by m, because these are atoms. So in that atom's motion we have to take most probable distance, so speed. Most probable speed is root over 2 kVt by m, where k is Boltzmann constant, T is the temperature, and m is the atomic mass. M is atomic mass here. Okay, so I'll use this formula now.
सर
Yes.
इसके पहले ना हम जब भी ऐसे देखते थे चेम्बर के अंदर, तो हम क्या बोलते, मतलब एक थ्योरी का नाम नहीं याद आ रहा है, लेकिन हम बोलते हैं कि वो रैंडम डायरेक्शन में अगर मूव हो रहे हैं तो उसका नेट इफेक्ट 0 होगा, मतलब जब नंबर ऑफ एटम्स बढ़ जाएंगे तो ऐसा कंसिडरेशन यहाँ क्यों नहीं कर रहे हैं हम?
No, you cannot apply these things here, because you see, when they are moving towards the observer, of course we will get some different energy. Photon will have, let us assume, when it is its original energy is, let us assume 2 electron volt. Its original energy that is originating due to electron transition. But when it is moving, this photon, when they are originating, it will move, it may move towards observer. So due to this photon, that observer will observe the energy corresponding to this photon. Let us assume that will be 2 point on. So that will give on line, you know, on particular specific omega, right? When it will move away, it will, the original energy is 2.2, but when it is moving away, the observer will observe energy that will be less. Let us assume that will be 1.1. So it will be somewhere here. But why you are getting other term? Because it may move at some angle, right? It may move some angle with respect to this object. That will contribute that velocity towards observer. One component will contribute, right? So that will give some other frequency. And similarly, this side, it may move in this direction also. So one component will be away from that observer. That will give other frequency. So there are many random directions. That's why we will get many frequencies. But it will never cancel, because here we are not talking about that interference, because there will be no interference, because the photon emission is random in direction and random in time. So it will be cancelled if there is a interference, and interference can only occur if they are producing at the same time at the same position. But since this emission itself is a random process, there will be no cancellation here. And due to different direction, the motion is different direction, right? Atom is moving in different direction. That's why you will get many frequency. Okay, is this part clear?
Yes.
Sir,
Yes.
सर यहाँ पर जो वेलोसिटी है
Hmm.
सर वो रिलेटिविस्टिक वेलोसिटी है, सॉरी माने कंपेरेबल टू सी स्पीड है.
You see, that's not confirmed. That's why there is a modification. Question is really good, but they never thought like that. So what they have considered, then they didn't talk about relativistic or non-relativistic. What they have taken from Maxwell-Boltzmann distribution, there is a most probable distance, right? A most probable speed, right? That is Vp equals to root over twice kt by m, right? So Maxwell-Boltzmann distribution is basically your classical, right?
Yes sir.
हाँ. So they
और
have
सर जो इफेक्ट है वो तो सर ई कंपेरेबल टू सी के रेस्पेक्ट में हम करते हैं.
exactly. That's why there is a modification of this. So what they have seen, by taking that V, they have substituted V here because you have V here also, right? I forgot to write this. There's a V here also. So they have substituted that V. So what they have, they got omega d, that is I will take mod value omega by c and root over 2 kt by m. 2 kt by m. But when they are performing experiment, that spreading in frequency, they are getting high. So that value, that factor they have included. Southern you may go through in details. They are getting high value. So they have introduced this factor. And there is no reason why they have introduced. Whatever they have got in experiment, that was this frequency, that speeding in frequency. By using this formula, they are getting this. But according to experiment, there should be one factor. So that if you include this factor, the speeding in frequency will be 1.67 omega by c into root over twice kbt by m. M is your atomic mass here, okay? So you can write in terms of nu also. So mod of delta nu d, that will be 1.67 nu by c root over twice kbt by m. And same thing you can calculate delta lambda d also, because nu equals to c by lambda. So you can calculate, but this formula is important for your exam. Is this part clear to all? So by using theory, they are getting this part, but when they are performing experiment, they observed there should be 1.67 multiplication factor. So they have introduced this. Is this part clear to all?
Yes sir.
Okay. Is there any more questions? So this is all about your atomic physics. Is this part clear to all? If it is okay, then I should stop here.
Okay sir.
Okay, then from tomorrow we'll discuss about molecular. Okay. Okay, then bye.
Thank you sir.
Welcome.
Thank you, sir.